Welcome back to Applied Algebra and Trigonometry. Today we're going to do a little introduction to functions. A function is a relationship between two variables, so that for every value of the first, there's only one value of the second. And we often express a relationship like this with an equation, such as y equals x plus 2. This equation indicates that there is a relationship between x and y. So whatever value you put in for x, you can determine what y is by adding 2 to that value. So we often express this relationship by writing a t-table or demonstrate the relationship by writing a t-table. For instance, if we put -2 in for x, right there, what does y equal? Well, y then equals 0. And we can go ahead and do this for every variable, any variable that we want to put in here. We could even put in pi. However, if we put pi in here, unless we want an approximate answer, we can't add these two. That is the exact answer. If x equals pi, y equals pi plus 2. But another way to write this equation involves changing this y to a different expression, changing it to the expression f of x, or the function of x. Likewise, instead of putting y in this second column, we could place f of x, or the function of x, at the top of the column. Note, f of x does not equal f times x. It means something different. This function, f of x, means that you're going to add 2 to every x to make this function. Okay, you can read it the function of x. Sometimes we read it the function f of x, because sometimes you're dealing with more functions and you have to use more letters of the alphabet. Also, this variable can change. The nice thing about function notation is that it very clearly says this is the function of t. T is our independent variable, and this other variable depends upon the value of t. So we have an independent variable and a dependent variable. What is the value of this variable? I don't know. It depends upon the value of this variable. But the moment I know the value of that variable and I have the function written out, I can figure out the value of the dependent variable. And let's look at some other functions. How about the function g of t, such that the function of g equals 3 times t? Or the function h of t, where it is equal to 5t squared minus 2t plus 6. But not so fast. Let's take a look at this again. This function tells us what to do with t. So you should be able to tell other people what to do with t by reading this function. In fact, that's one of the things we're going to do in the homework, is you're going to write out in English what should be done to the variable or the input to produce the dependent variable or the function of the independent variable. In this case, you would square t first, or square the variable, or square the input. Input is the word that my lab math prefers, so that's what I'll use from here on out in this problem. And multiply that value by 5. That takes care of the first term. As I move on, I remember the order of operations and the mnemonic PEMDAS to tell what to do next. I have no parentheses. I took care of the exponent that I had. So now, and I did one multiplication, I'm looking for another multiplication, and there it is. The next step is to multiply the input by 2, and then subtract that from the previous calculated value. And then our last step will be to add 6. These exercises will help you understand how to communicate mathematical ideas to people in English but I hope it will also give you a deep appreciation for how much mathematical symbols simplify our communication. Part of what mathematics is it's a language. It's a language to communicate ideas. Here is a set of instructions in English. Let's see if we can work this out. Square the input. Let's see. I think I'm going to let the input be represented by z. So I'm going to square the input, and I'm going to multiply the input by 2. So I'm going to write that as 2z. Then I'm going to add the two calculated variables and subtract 1 from the sum. So PEMDAS would tell me, square this, do that multiplication, then add, and then subtract 1, which is what the English instructions told me to do. So let's go ahead and name this as the function of z. So the function of z equals z squared plus 2z minus 1. And let's put some values in for z. For instance, let's start with, I don't know. Let's do f of 3. Okay, so 3 goes in wherever there's a z. And I highly recommend when you are getting ready to substitute variables, put in parentheses where the variable will go. Don't put in the variable immediately. Don't put in the value of the variable immediately. It's not as important when you have a positive. I'll show you a negative in just a little bit, and I'll show you an example too, in which it's very important that you put in those parentheses so you don't make an error. Okay, so 9 plus 6 minus 1, 15 minus 1 is 14. So the function of 3 is 14. So let's look at the function of negative 10. Within the parentheses that I left in place there, I'm going to put my negative and the 10. So the function of negative 10. Negative 10 squared is 100. 2 times negative 10 is negative 20. And subtract 1. So my final answer is 79. That is the function of negative 10. I shrunk that down a little bit because I want to write another function over here. And because I am using a different function within this same problem or this same screen, I'm going to make this the function g of z. And the function g of z is defined to be negative z squared minus 9. So let's put some values in for the z in the function g of z. Let's start with 2, a simple one. So notice that we have a negative here. Then we have our z, which is squared, minus 9. Okay, so now I'm going to do something I will do throughout the semester, which is to take a break from the problem. All right, we will get back to that, but I want to point out something very important, and that is that negative 3 squared does not equal parentheses negative 3 close parenthesis squared. The expression on the left-hand side means the negative of 3 squared, or 3 times 3. So it means negative 9. On the right side of the parenthesis, you are taking negative 3 and multiplying it by itself to get a positive 9. And those are clearly not equal. So whenever you see a negative in front of some term, remember that unless that negative is within parentheses and then you have it raised to some power, it means evaluate the power first and then make the answer negative. Let's go just one step further. What if you had negative 5 squared? Okay, with the negative 5 within parentheses, this says you square that first, which would give you negative 5 times negative 5 gives you a positive 25. but this negative remains on the outside. So the answer would be negative 25 if you were asked to evaluate this expression. Okay, enough of that. Let's get back to the original function we were working with. Okay, putting a 2 in there. There we go. Okay, and by putting in the parentheses originally, I clearly indicated that this negative was not squared. So 2 squared is 4, and that is negative because the negative was outside the parentheses. And my final answer is g of 2, or the function g of 2 equals negative 13. Okay, let's compare our functions by putting negative 10 in for z in the function g, as we put negative 10 in for the function f previously. So I'm going to put in my parentheses where the z is and make that squared minus 9. And now I'm going to input the 10. Okay, so I have a negative. What's in the parentheses? Well, what's in the parentheses is squared, so negative 10 squared is positive 100 minus 9. So that gives me negative 109. So the function g of negative 10 and the function f of negative 10 return two very different numbers. All right, I'll give you one more example before I turn you loose to read your book, to gather more pearls of wisdom, and then start your homework. So here is our new function, the function h of g, and we're going to evaluate that for the following values of g. We're going to evaluate that when g equals 0. So that would be 0 squared minus 2 times 0. Well, that's just all 0. All right, let's do something a little different. Let's compare two things. Let's compare the function h of g minus 1. Let's figure out what that is equal to, and let's compare that to h of g minus 1. Okay, see what I'm doing differently? In the first one, I'm just looking at the function and I'm going to substitute g minus 1 wherever there's a g. Kind of a strange thing to do, but we can do it that way. Okay, anything we put in that original parenthesis can go inside these parentheses when I'm evaluating the function. Okay, so I'm going to have to do g minus 1 times g minus 1 for that first term. And I'm going to have to distribute this 2 to evaluate the second term there. And it's a negative 2, so I'm going to take the negative with it. So negative 2 times g is negative 2g. Negative 2 times negative 1 is a positive 2. And now I have to distribute every term in the first parentheses to every term in the second set of parentheses. Okay, so I get g squared minus g plus 1 minus 2g plus 2. Ooh, I'm going to have to move up a little bit. Let's make it a little smaller as I go. A little smaller and move it up. Okay, so I have g squared minus 2g plus 1 minus 2g plus 2, which gives me g squared minus 4g plus 3. Okay, let's see how that compares to h of g minus 1. All right, so I'm going to look at my original function up there, and I'm going to put whatever my value is in, and I'm going to square it. Then I'm going to take negative 2 and multiply it by the value of my variable. But then I still have this minus 1. So I have to go over here and subtract 1. Okay, and the value I'm putting in is found right here. I am putting in g as the value of my variable. So g squared minus 2g minus 1. So let's summarize what we have here. First, let's get this out of the way. And we'll bring this down here. Put those equal. The function h of the quantity g minus 1 equals g squared minus 4g plus 3. But on the other hand, the function h of g minus 1 equals g squared minus 2g minus 1. Those are very different outcomes. They are not equivalent. Because we're covering a lot of ground in different areas in this course, we're not going to get into the composition of functions, but just in case you're curious, I will work one on the end screen so you can look at it and you can find lots of examples in your book if you just dig for them. But what I've shown you so far is what will be covered on the homework and what we will be using as we go forward in the class. As always, let me know if you have any questions. I look forward to seeing your smiling face in class.